Okay guys, in this video we are going to look at solving algebraic inequalities, just like this one, 5x plus 3 is greater than or equal to 38. So the good news is this is very similar to solving algebraic equations. Is it the same as solving equations? Well, sort of, and you'll see why there's a big catch here. But so to solve this inequality, I would solve it just like an equation. I would subtract 3 from both sides, isolate my variable, divide by 5 on both sides. That gives me x is greater than 7. So I did all the same steps as if it was an equation instead of an inequality, and I got the right solution. And so it is sort of the same, but there is a difference also in what the solution means. The solution doesn't mean x is 7. It means x is greater than 7, which means that x can be anything higher than 7, and it would maintain the truth of that original inequality. And to check that, I could just pick anything that's higher than 7. So I would check, I always do 10 or 0 if I can, because they're easy to work with. So 5 times 10 is 50, and then 50 plus 3 is 53, since 53 is greater than 38. So therefore, my solution is correct. I picked a value that was greater than 7, and it worked. Okay? So there, I just solved it like an equation, and it worked. Okay? But there's one big catch to all this, so please pay attention, stay tuned, because there is one catch to solving inequalities. All right? The good news is that in many cases, this doesn't apply. So here again is a 25 is greater than or equal to 2x plus 3. So again, just go into your solving equation steps, take away that 3 constant, divide by 2 to isolate your variable, and you get 11 is greater than or equal to x, or x is less than or equal to 11, right? Which means that x can be anything 11 or lower to maintain the truth of the inequality, all right? So what's the catch? Well, here's the catch. The catch involves a phenomenon that happens when you're operating on both sides of an inequality. And what I mean by operating is adding, subtracting, multiplying, dividing. And let me show you what I mean without any variables. So here is an inequality, negative 10 is less than 5. So right now it's set up as the lower side is less than the higher side. Now, if I do something like subtract both sides of it, right, I'm going to take away 2 from both sides. I get negative 12 is less than 3. Now, that is true. Negative 12 is less than 3. So subtracting didn't change the truth of the inequality. If I add 10 to both sides, I get negative 2 is less than 13. That's true, too. Negative 10 or negative 2 is less than 13. So adding and subtracting did not affect the inequality in terms of which side was greater and which side was lower, right? Which is one of the reasons that we can solve it like an equation. Let's take a look at multiplying and dividing. So same thing, I'll start with negative 10 is less than 5. Again, it's set up as lower side is less than the higher side. So if I did something like divide by 2, if I divide negative 10 by 2, I get negative 5, and 5 divided by 2 is 2.5. And 2.5 is greater than negative 5. Negative 5 is less than 2.5, right? That's a true statement. So dividing didn't do anything in terms of the truth of the inequality. Kept it true. So what about multiplying? If I multiply by 4, negative 5 times 4, and 2.5 times 4, that gives me negative 20 is less than 10. And that's true too. So multiplying, dividing, adding, and subtracting did not affect the truth of the statement. So here comes the catch. Here it is. I'll start over again. Lower side is less than higher side. Negative 10 is less than 5. Now I'm going to divide, but this time I'm dividing by negative 2, and this will change things. I'm dividing both sides by a negative. What happens is negative 10 divided by negative 2 is positive 5. And 5 divided by negative 2 is negative 2.5. And now the inequality says 5 is less than negative 2.5. And that's not a true statement. In fact, the exact opposite is true, right? I've switched which side is higher and which side is lower. Once I divided both sides by negative, I've changed the polarity of each side. Of course, there's an easy fix. I could just flip the sign the other direction, and you'll find that when we solve inequalities, that's exactly what we're going to do. If we're dividing both sides by a negative, you have to remember to flip the sign in the opposite direction, because by dividing by a negative number, you're changing. If a number's positive, now it's negative. And if a number's negative, now it's positive. right? And so that makes a difference. You have to remember to flip the sign. Let's check it out with multiplication as well. So here we go again, same thing, lower side is less than higher side. If I multiply both sides by -3, that will have the same effect. -3 times -10 is +30, and 5 times -3 is -15. And -30 is not less than -15. That is not a true statement. I've changed the polarity of the sides because I multiplied by a negative on both sides. So I just have to remember to flip the sign, okay? And then that will make the statement true. 30 is greater than -15. Okay, easy switch, flip the sign. Let me show you how this applies in actually solving an inequality. So here I have 10 minus 4x is greater than or equal to 30. So I'm going to take away that constant. That's going to give me -4x is greater than or equal to 20. And then I'm going to divide by -4, right? Now, right there, I'm dividing both sides by negative, so I have to remember to flip the sign in the other direction. Because if I don't, it won't be true. To check my solution, right, I have to pick a value that's lower than -5. So I will pick -10 because it's an easy one, and I just plug it back into the original inequality. So I do 10 minus 4 times -10, and that's going to be 10 minus -40, which is 10 plus 40, which is 50, and that 50 is greater than 30. So I am good. I did it correctly. Right? Now, let's look at that same problem, but let's do all the same steps. Subtract 10, divide by -4, but forget to flip the sign. So I was supposed to flip the sign because I divided both sides by a -4, but I forgot. Well, now when I go to check it, x has to be greater than -5. Oh, I know what number I'll pick, a 0. 0 is greater than -5. So when I go to check it, I plug in a 0. And I do 10 minus 4 times 0, which is 10 minus 0, which is 10. And it says 10 is greater than 30. Well, that's not true, right? And I know that my solution is incorrect because when I went to check it, it was not true. And the reason it's not true is because I forgot to flip the sign once I divided both sides by a negative number, therefore changing the polarity of the inequality and which one's higher and which one's lower. Now, if you can remember way back to when we were solving variables on both sides, I say way back, but it was very recently. We were solving equations with variables on both sides. One of the things that I said was try to solve it as the variable equals a constant or a constant equals a variable based on which side will have a positive coefficient. And I said that keeping the coefficient positive can make things easier, especially later. Well, that later time is now. This is when it makes it easier. Take this example. I have 8 minus 5x is greater than 2x plus 22. So if you actually did that, like, hey, which side has a greater value for x? And I see that it's the 2x side. 2x is greater than -5x. So if I isolate the variable to that side by adding 5x to each side and then subtracting 22 from each side, right here, I have to divide by that coefficient, and I'm going to be dividing by 7, which means I won't have to remember to flip the sign. Right? I just divided by 7. The sign stays the same direction. X is less than -2. So to check that is a little tricky because you have to plug the number into both sides. So -10 is less than -2. So I'll plug -10 into both sides of the equation or the inequality. And when I simplify it, so I'm multiplying by -10 to the -5 and to the 2, and then I simplify and it says 58 is greater than 2, right? And that's true. 58 is greater than 2. And I was good because I didn't have to flip the sign because my coefficient was positive, and when I divided, it wasn't dividing by negative. For the same exact problem, let's say you're like, hey, I always solve, I put x on the left, I never think about how many are on each side. Okay, that's fine. But notice that when you go to start to solve this, so I'm taking that 2x away from the right, now I have -7x over there, and I take away that 8, and I still have that -7x. Now I'm dividing by -7, which is totally fine as long as you remember to switch that sign, because you're dividing both sides of an inequality by a negative number, okay? If you multiply or divide both sides by a negative, the sign has to be switched the other direction, all right? So, and I have right here a little note, by keeping the coefficient, by not keeping the coefficient positive, you will have to flip the sign at some point. All right. And that's if you're solving inequalities with variables on both sides. So the good news is that solving inequalities is the exact same thing as solving equations. If you know how to do one, you know how to do the other. The only catch is that you have to remember to flip the sign the opposite direction if you multiply or divide by a negative number, because you're changing the polarity of the sides. Okay? So as long as you pay attention to that one thing and you can solve equations, you'll be an inequality master. Good luck.